the first thing we have to distinguish when we look at our third category of naming is what is an acid. First of all, can you just tell me some properties of acids? Do you know much about an acid that you see in everyday life? What are some examples of acids we see in everyday life? Yeah.
Vinegar.
Vinegar, yep. What else? Yeah.
Lemon juice.
Yep, lemon juice, lime juice, any citrus, yep.
What about like on the scale of the pH scale?
Mhm.
On these
That's right. That's right. What's neutral on the pH scale?
water.
7, or water. Yeah, water has a pH of 7, which we consider neutral. But acids are on the pH scale, right? What's the opposite of an acid? A base, right? So it's either acidic or basic. But when we talk about compounds that are acids, acids are compounds that when they ionize, okay, let's talk about what it means to ionize first of all. When they ionize, it forms an H plus ion. Okay, so let's tell me first, what is an ion? What is an ion? Any particle with a charge. Okay, so when a molecule ionizes, when something dissolves, it breaks into its individual ions. Okay, that's what ionizing means, right? Ionize means breaks into individual ions. Okay, so let me give you an example of NaCl. NaCl, do you know what compound that is? It's salt, right? That's typical table salt. And when we put salt into water, it dissolves or it ionizes. And what that means is that the sodium and the chloride separates and it left with Na plus 1 and Cl minus 1. Right? That's what it means to ionize. Okay, so it says an acid, when it dissolves, it ionizes to form an H plus ion. And so that means in order for it to dissolve and have an H plus ion, an acid has to have hydrogen in it. It must be hydrogen plus something else. So a big clue for us with acids is that there are hydrogens at the start. Okay, hydrogens at the start of the compound. Okay, in acids specifically, the hydrogens come first in the compound. Okay, and that's just kind of the way that acids are written. But hydrogens will always come first. It'll have a plus charge, and it will be paired with some anion to form an acid. Okay, so hydrogen plus some anion will form an acid. Okay, so let me just give you some examples of acids. HCl, H2SO4, H3PO4, right? Those are all examples of acids. And we know that they're acids, we can tell because hydrogen comes first. Okay, so we treat them like an ionic compound in that they have to be balanced. Okay, so that's another little bullet point here. They must be balanced. Okay, must have an overall charge of 0. They have to be balanced. But we don't have to do a lot with the crisscross charge because hydrogen is always plus 1, right? And so it's easy to figure out how many hydrogens have to be paired with our anion to make it balanced. Okay, so it's going to be an easy fix for us. Now, the rules for naming acids follow a certain kind of code here, and I give you this cheat sheet, and you'll be able to use this whenever you need it. But it tells us that if the anion that we are paired with ends in 8, those would be things like phosphate, nitrate, carbonate, right? Things that come from the box on your periodic table of ions. If it ends in 8, you would be calling it something, right? The what's it called? The root of the element, and then ic acid. So let me give you an example. This one right here. If I take away the hydrogens, I would be left with SO4 minus 2, which is sulfate. And so the name of this acid all together, H2SO4, right? Hydrogen plus sulfate is called sulfuric acid. Okay? It ends with an ic, and acid comes after that. It ends with an ic and comes with acid. Take a look at this first one right here, HCl. If I took away hydrogen, what would I be left with? Just Cl minus. And so what's the name of Cl minus 1? What's just chlorine by itself called? It's called chloride. And so look on your cheat sheet. If my acid comes from an ide, anion, what would I call it? Hydrochloric acid, right? It gets the prefix hydro. This is the root. This is the root. And it ends in ic, acid. Okay, so you're always going to get to use this little sheet, but it'll help us figure out how does each get their name. Okay, so let's do a little practice here. I think I've just got on the next slide this same table, except I added 1 to it. Okay, 8 to ite is 1 less oxygen. 8 to per something 8 is 1 more oxygen. I don't have you memorize that, so I don't need you to worry about that necessarily. I'm just going to make you stick to this one. Okay, so we don't have to necessarily worry about this top one right here. If we see it, we can work through it, but we don't need to worry about it too much. Okay, so let's do a few practice examples. Let's say that I want you to figure out what is the formula for phosphoric acid. Okay, I've got to first figure out what are the prefixes or suffixes added on here, right? It's just ic. And so that means the acid must come from what anion? Okay, and say the whole name. It must come from what? Phosphate. So I need to find phosphate. And what is the formula for phosphate? Okay, I'm going to look in my box. Right? What is it? PO4 minus 3. And so is this the formula for phosphoric acid, just PO4 minus 3? No. What has to go with it? A hydrogen has to go with it. And so how many hydrogens have to go with it? 3. Okay, and so we're going to put these together in our ratio that makes it balanced. So H3PO4 is the formula for phosphoric acid. All right, does that kind of make sense how that comes together? You've got to figure out what anion it's coming from and then how many hydrogens we need to pair with it to make it neutral. Okay? What if we had carbonous acid? Okay, carbonous acid. It comes from carbonite. Okay, good. Okay, so let's figure out from our table, what is the formula for carbonite? Is it on our table? It's not. It's not in the box, but what is in the box? Carbonate. And what do I know about carbonite? We take away an oxygen. So what's the formula for carbonite then? CO2 minus 2, right? CO2 minus 2. And in order to make it an acid, I have to pair hydrogens with it. And so the formula for carbonous acid is H what? H2CO2. And do I reduce those down? I don't, right? Because this too is part of carbonite's identity, right? And so that means that it is non-negotiable. Yes?
So for like the carbonite and the carbonate, you said that you take off one oxygen, but do you also change you don't change
The charge does not change at all. Nope, that's a good question, but the charge does not change. Okay. Give me the name for this acid, HF. Nope. It's got to be an acid. It has to have the name of an acid. Okay? Yep, I would agree. Hydrofluoric acid, right? I know that because if I ignore the hydrogen, I would be left with F minus 1 which is fluoride. Okay, and fluoride means it's hydroic, right? These right here are called binary acids. Okay, and binary acids have hydroic, right? What do you think it means when I say a binary acid? Just two elements, right? Hydrogen plus something else. These are called oxy acids. Why do you think they might be called oxy acids? Because they contain oxygen, right? That's it, right? So we have two kind of categories of that. We don't name them any differently, but if you can remember that a binary acid is hydroic, it might speed up your process a little bit, okay? All right, give me the formula for iodic acid. Iodic acid. We're going to start with, I'm just going to put up chemical formulas, and you're going to give me the written names. Okay, chemical formulas, you give me the written names. All right, so I've got 3 compounds up there. First thing you have to do is decide, is it ionic, is it covalent, or is it an acid? And then name it correctly. Is it ionic, covalent, or is it an acid? It is covalent. I would agree. I know it's covalent because it is 2 non-metals. They're both found on this side of my periodic table. Okay? So that is covalent. I would agree with that. What about the second one? Ionic, covalent, or an acid? An acid. Good. I think those might be the easiest to identify because what element comes first in an acid? Hydrogen, right? Hydrogen will always come first in an acid, and so that's our identifier. Okay, so this would be an acid. And then what about our last one? Is it ionic, is it covalent, or is it an acid? It's ionic. I know because it contains a metal. It's the only category of naming that we contain metals. Okay, so this would be ionic. Okay, so let's go through and name each of these. With the covalent one, C3O2, do I have to do any crisscross? Do I have to do anything to adjust it? I'm just going to name it as I see it. Okay, so let's go with the first part of it. There are 3 carbons here, so what would we call that? Tricarbon, right? It keeps its regular ending. And the second part of it is O2, which would be dioxide. So tricarbon dioxide. Good. Did anybody get that? Good? Okay. The next one, it is an acid. So we're using our acid rules, right? Our little cheat sheet. We have to figure out if we ignored hydrogen, this PO3 would be what? It would be phosphite. Okay, so this isn't our name, but I'm writing it down as a clue for us here. It would be phosphite. And so to name that acid, I would call it phosphorus acid, right? That would be our name, phosphorus acid. All right, and then our last one is ionic. And so we've already done the crisscross, right? They're already balanced. So I need to figure out how do I name it, right? And with naming ionics, the cation keeps its name. The anion ends in IDE. But we have a polyatomic ion here. So it keeps its regular name. So give me, what's this element right here? Chromium. And so I need to check the periodic table. Is it going to need a Roman numeral? It is. So we're going to hold on to that for a second. We're going to put a Roman numeral in the middle. But then what's my polyatomic ion that's here? Phosphate. Okay, so it's going to be chromium something phosphate. I've got to figure out what's chromium's charge here. Okay? If they fit together 1-to-1, which it looks like they do, and I know phosphate has a -3 charge, what must chromium's charge be? +3. Okay, so chromium 3 phosphate. Okay, does that feel a little better? Okay, let's try another round of these, except I'm going to give you the written name and you give me the formula. Okay? All right, I'm going to give you the written name.
Wait, did you mean to write phosphate at the end? Or it wouldn't be phosphate?
This would be phosphate. Yep, because it's PO4. If it was phosphide, it would just be a P.
Yeah.
Just P. Yeah. So I think I wrote phosphate. Yeah. Okay. Let's see. Gold. 1. Bless you. All right, so I have 3 there that I've given you the written name, and you're going to give me the chemical formula.